Okay, hello. Hello. Hello, hello. Test. Okay, hello. Okay, working. Hello. Hello, hello. Test. Okay, there's a bit of lag, but I think we are set. I changed my software capture for Open Broadcaster software. We can have now the chat in on the side automatically. I had to resize the construct windows because it seemed it doesn't work to capture the canvas when I use OBS. Anyway, today we will talk about arrays. Arrays. I will rename the broadcast to arrays. Why are we talking about arrays? Because someone on the forum asked something about saving data, RPG data for games. Well, I thought before trying to come up with a solution for his question, I thought about talking about arrays, because we would probably use arrays to store data for an RPG, and our arrays aren't necessarily well understood. So my ideas, there's already tons of tutorials on arrays. They are not bad, they're quite nice, but I will try a different approach, because how should I put it? Understanding something, you can understand something by using it often. But you can really understand something when you are making it, and we will make an array system using something else. We'll use functions, and that's all. We'll use functions to mimic I will put an array in the editor, but I won't use it. I will just check that I will be able to mimic the functions we already have. To check our our test, we will put a text box here. I will activate the snapping so it's nice. Text box, okay, and set it to text area, and because I like to do it read only, yes, okay. I will create a functions to write stuff in this text box a little bit more quickly. I will call this function print, and it will be text box set text to self.text, and the parameter of the function, I will rename that to f soon, and a new line, function f. Okay, and so we can use this function to do something like start of layout, call function print, add parameter, blah blah. You can do that over and over, and it will write blah 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 blah. So that's working great. Okay. Okay. So what do we want to have with our array? I didn't prepare this video, I just had it in my head. I'm not sure I will be able to do everything that I said, but I will try. Printing console in quotes because it's not really a console. So okay, we want to first write in our pseudo array x, xy, xyz, set size and clear. Okay, set size, this function needs 3 values: set size, width, height, depth. Okay, we'll have set at x, just need 1 value, set at x index x. Okay, set xy, and set at xyz. Okay, I have the condition. For now we'll look at the actions. Okay, and clear. Clear. Okay. Clear the array. So now a little bit of talk about arrays. What are arrays? In programming, we have variables. Variables are just a name given to a data, and the data in simple variables like we have in construct are numbers or strings. But strings isn't really a simple data. Simple data in a computer are just numbers, are just one numbers. As soon as you have many numbers, many data, a string, many characters, it's something we call a data structure. An array is a data structure, a string is a data structure, a dictionary is a data structure. An array is almost the same thing as a string. A string is a specialized array. It's an array that stores characters and makes words, etc. An array is something a little bit more global and stores datas, a list of datas. In construct, we have x, xy, xyz, and you often hear a 1D array, a 2D or a 3D. 2D, 3D. But in reality, there's no such thing as 2D and 3D. It's just an arithmetic thing that helps to organize data. We will see that by working on these functions. What we will use to hold our array system is a string. We will use a string and separate each of these cells of data by a special character. and we'll use the pipe characters or the vertical bar character. So we will define it as, where is my cursor? I lost my cursor. Okay. Escape. Okay. My Drover program mess up with me. So we will create a separator. We'll use the pipe and we'll set that at constant. Okay. That's our separator. Basically, we'll also create our array, which will be a text and empty at start. So basically, we want to use something like something pipe something else, pipe another value, pipe, etc. That's how our array will look. Here we have an array of 3 elements, 1, 2, 3, and it would be with the array object an array with the width of 3, the height of 1, and the depth of 1. Okay. So let's see how we will implement that. The first thing we want to do is set the size of the array we want to make. How will we do that? We will need to have a width, a side, and a depth parameter. You already have that in the array object here, so we need this information as well if we want to mimic this behavior. Number and depth. Number. They are not constant because we can change them here, and we'll set them to 10, 1, 1 by default. Okay. What happens when we start construct and we have an array with a size of 10, 1, 1? The array already have a value in it. This value, and you can see we'll print it. Print array at 5, for instance. It will print where are you? Where are you? New project. Okay, it will print 0. So by default, the array is filled with 0. So how maybe it's not filled with 0, but construct choose to display 0 when there's nothing, but we'll start with the array is filled with 0. So on start of layout, we will run the set size function to create our array filled with 0, which will look like something like that. System set value array will look like that 10 times. But we don't want to set it by hand. We want the set size to set it for us. And basically, we will do that by running a loop. Width times height times depth. why do I have I did some copy pasting, so I have the print code everywhere. Okay, so repeat for width, height, depth. We will set everything to 0. So add to value 0, and we want to add the separator, but the first time we'll add the separator before the 0. Separator, but the first time we don't want the separator. Here, let's test what the set size does. We call set size, okay, and we'll print the result array. Okay, our problem is the first character is a separator and we don't want that. We want something clean. So what we can do is a local variable named separator. Okay, and it's a text, and by default there's nothing. Instead of adding the constant, we will add the local variable separator, and then after the first iteration we'll set the separator to the actual constant. So if we simulate what's going on, it will run 10 times, and the first time it will add nothing to the value array, then the 0, and then the separator variable will be set to our vertical bar, and then it will add the bar, etc., etc., add the bar, etc. So the result will be what we expect. Here is the representation of a 1D array of data, an empty 1D array of data. So, okay. Let's see. So you can see we have a representation of our data like cells, 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 cells. That's an array. Maybe the thing I didn't yet explain is why I use that. Okay. For now, we will just work on a 1D array, and we will add the dimension afterward, so this makes more sense for now. A 1D array is just a list, a series of data. Okay, so on a 1D array we can do a clear. A clear, the function of a clear is to set every value of the array to 0. We will check that with the array object. The array object, we can do something like for each element, for each x, set the value at x self dot cure value, cure x by random number between 10 to 20, and we will then rerun the same loop and print the values. your value. And we'll see here there's random stuff. If we clear the array and redisplay the same exact data, we'll see it's back to a list of 0. So the clear function filled the array with a list of 0. It does exactly the same thing as that. And here we can see that I made a mistake, because the set size shouldn't overwrite what's already in the data. What the set size should do is, if there's some data, keep it. If you give a dimension greater than what was the array, you would pad the difference with some 0. If it's shorter, you will erase the data there was and keep the data that already were in the array. So here is in fact the code for the clear. I told you I will make mistakes, and here we are, mistakes. So it's the clear value. What is the set size value? The set size value will run the same exact loop and recreate the string by picking the values in the original arrays, and if there's no values, putting some zeros. How will we do that? First, we have to have some functions to get values in an array. Since I told you I will first work on one-dimensional arrays, I will just toggle off the other 3-dimension and 2-dimensional array functions and just work with them. So the get at x is the same as, let's say, if I do a print array at, it's our function get at x. If we do just one value like that, it's get at x. So get at x, x in French, x in English. Get at x, how does it work? We have a string, I don't have it anymore here. We have a string with some separator, and those who already worked with it can guess the function I will use. It's token at. The function token at needs first a string, then I will run out of room, an index, and then a separator. We already have our separator, it's our constant, and we already have, and we know the index of the index will be the parameter we'll enter in this function. The string is our array, and the separator is the one that is over there. So we already have a get at x function handy. So we'll use return value token at text is our array, index is f.parent 0, and separator. Oops. Okay. This should return a value at a specific index. Now, since we broke our setSize function, I will use the clear function instead. Does what it was doing. So array textbox function. Okay, print. Array. Okay, so we have our array, and we want to get a value anything. Here it won't be really representative because we only have some zeros. But what we can do, we will write first the set at x, and we will check both functions together. The set at x isn't as straightforward as the get at x, because we need to know where to put the new value, and it's since it's a string parsing, it's the part I didn't really anticipate, and it will be a bit hard. We will need to find where in the array to insert the value. It will be a pain. So let me think. What can we know if we want to say set index at 5 to something? 0, 1, 2, 3, 4, 5. So I want to be able to keep all that and put the value in here. The solution I have in mind is to is pretty inefficient, but it will probably work. Is to do a loop through the array and recreate the array with the new value in it. Maybe you have a better idea, but for now I only have that one. So repeat token count array, and I need my separator. It looks ugly. I will create a variable so I can put this ugly expression in it. Set value size and repeat size. Okay. So we'll go 10 times and we know when to stop. So we'll have if loop index equals, I will create another variable index and set it to f.param0 index. This way it's easier to look at that than to look at that. So if loop index equal index, we want to insert our values. Our value. Insert new value. So I forgot value. That's here. Value and value. And else we keep the old one. Keep the old value. And we have to create the new array variable, which will be a text. So basically we will read our array our array over there. We'll read through each of the token inside. To be, I don't know if I explained that correctly, but here the cell I was representing and our array with 0, 0, 0, 0, it's the same. This is the separator. This is the token. So if you say token at 2 with a separator of vertical bar, you will get this token. If you use token count, you will get 1, 2, 3, 4 token. Alright. So here I will the loop will give me a number, loop index, which will go from 0 to size minus 1. So it will go from 0 to 9. So I will be able to do the exact same thing as I did here, and after the first insertion do that. Then I'll be able to either add token at array loop index separator, or add our value. I didn't create a value x value index value, which is our second argument of the function. First, second. Okay, here value. Alright, and we want to add the same way we added here the separator first. So for a summary, the function now should work. What does it do? If we do something like my shortcuts, set at x 5 plop. Here value will be equal, index will be equal to 5 and value will be equal to plop. Our size will be 10. So the loop will go 10 times. First time the separator adds nothing. Then loop index, first time loop index is 0. First time 0 here. It will add, since it's not equal to 5 here, it will not run that, but it will run that one. It will add to our array I made a mistake. I have to use new array. It will add to new array. I will change that just after I finished. It will add to new array the value at 0, considering the separator or vertical bar, from the string of the original array. So we'll have, in our case, with our starting array, we'll have a 0 added to new array. Then the separator will get its vertical bar, and next iteration, loop index equal 1, separator equal vertical bar, it will be added to the array, so it will look like 0 vertical bar. Still, this one won't be equal, so we will have the else running, adding a 0, etc, etc, until we reach loop index 5. This event will run, add our plop, etc. until the end of the function. I hope my drawings are readable enough, so I will change that to new array, and it should work. Okay, clear array, set at x call function, set at x plop, no, first the index, then plop. Okay, and we will print the array, and we will also print f.call get at x 5 to see if we get the value we entered, and just for the sake of testing, another value which should output 0. Let's see. Okay, there's a problem. There's definitely a problem, which is that I have to change everything here, obviously. And one last thing is I have to overwrite the old array with the value of the new array. New array. A. Let's see. Okay, NaN. It's not a good sign. Yeah, we are almost there, but not quite. Why doesn't it work? F param value. Okay, value shouldn't be a number. By the way, NaN means not a number, which is right. We don't want a number, we want a string. Okay, that's working. Plop, plop, and 0. So we are adding plop at 5, and then we get the value at 5, and then get the value at 3. There's one thing that we will agree to not do with our system, is to use the separator as a value we insert, because we'll totally mess up the thing. And second thing, we should have used width, not token count. Even if it's the same, if we decided to use value to represent, to tell about the array, we should keep this this mindset. Width, height, and depth can be called a meta data. It's something that describes data. So size no need. Okay, let's see. Okay, working good. Okay, set at x is working, get at x is working, so now we can achieve a set size. Set size will repeat with time, and will create a new array. And it will almost look like this one, this thing, and it will be if there's a value, copy it, else fill with 0. So we run that 10 times, and if there's a value, how does that look? If there's a value, it's not that, it's new width number, new height number, and new depth. We'll get that. I will only use for now the width, but it doesn't hurt to prepare for the next stage. New height, new width first, f dot param 0, height and width. Height 1, depth 2. Okay. So for now we will run new width time, and in fact if there the value is the same thing as saying are we under or over the old width. We don't have to do a get at x to check that. So if loop index is less than width, which is the old width, we keep our structure. It's the same exact thing we are doing everywhere here. Oh, when you end up noticing that you do the same exact thing everywhere, it's a sign. It's a sign that you should use a function to do that thing. So we will create a function, a new function, and put the old one on hold for now, which we will call add token. Let me do something first. Okay, add token. Okay, so this function, we will use this function as if we were outside of our array system. It's a helper function, so it will take as argument a string and value and the separator. These functions are our array function, so we assume we are using this value, but these functions over there are helper function. So I will create a group J group helper. Yeah, G, not J. J in French is the same as G in English. Mix up some pronunciation. So, add token, string value separator. I will create, for clarity, the value string text number value, which is a text as well, and separator a text as well. And what will it do? Well, if there's nothing in the string, you don't put the separator, but if there's something, you add the separator and you return the string. In the end, we return the string transformed. Do we add? We return the string. Okay, so we get first the value. String f dot param 0. The value will be 1, and separator will be 2. Then, if string equals nothing, you just add the value. Set value string. You set the value, the string to the value, and else you don't set but you add to the string, but before you add separator. Not this one, this one, and you return the string. Seems right. Let's test that. I will keep these ones but just toggle them off and print parameter f.call add token random gibberish the plop, we like plop, and anything. Okay, we'll test if there's nothing in the string, and we'll test if there's already a separator. Let's see. Tech, not working. Okay, that's not working. I only get the base string y. String equals else string to value else at array. What? Why is this here? String. Okay. Okay, working. Here. Okay. What was expected here was gibberish, arrow base, plop. Plop is here. Here we were expecting just plop since the base string was empty. That's what we got. And then here we expect 3 tokens since we already have 2 tokens, and we add plop. You have an arrow base and plop. So it's working great. So we have our helper add token. Let's see if we we will transform the function we already made, but this result should stay the same since we're just replacing what we did with the helper function. So set size, that's what we were writing. This one is working. This one. We don't need that anymore. We just need to add token. Add. We just need. Okay. Here we replace add value to new array to call function add token new array value separator. Okay, we don't need that anymore, and here we'll just add this big thing as a value. and that doesn't change here, so it's slightly less cluttered here. Do we get the same thing as before? No, we messed up something. Okay, array loop index add token new array. Should what did I do? I called the function that return a value. It returned new array plus the separator, the value, and concatenate as a new token. But the return value, the result isn't put inside the new array since you don't have access to new array in the other function. It's returned by the add token, but I don't get the return. I don't get the return value, so I didn't use it properly. It's what I should have done is set new array to f.call add token new array value separator, and then here same thing, but replacing the value with this. So now we should get our result back. Okay, doesn't look too bad. So now the clear is working. We can use that for clear as well, which would be set value array to f.call add token array 0 separator. Alright. Yep, working. And the good thing about functions is that when you check them, you know they are working right. You can forget about them and just use them as if they were part of the C2 functions. That's the great thing. You can forget about these ones. Alright, let's check if the clearing works. Alright. Array at token. There's something I want to do. As well as I set the separator over here, I want to set the empty values here as well. Because it could be anything. I could change my mind and say I want the empty value to be -1 or the string empty, or I don't know, maybe NaN, which would be right but not exactly explicit. So yeah, empty I prefer like that. Okay, clear, set size, everything is working. Oh, what if I think I did C2 channel. Create our array. Okay, and rename here too. Okay, so now set size is working. Get at x. Set size is not finished. Let's see set size. So new width. I don't need that anymore. If loop index. So I resume what I did. I can forget about this for now. Set size you set the width of our array to be 5. It was 10 and now it's 5. Repeat 5 times, it will go through and create the new array in the new array variable, and as long as the old width is greater than loop index, so for 0, 1, 2, 3, 4, it will add the value there were in the original array. But then if it's over width, it would add the empty value, 0. So set value new array to f.call add token. The value, it will get slightly complicated. We want the value at loop index, so we want f.call get at x loop index, and no, first new array, then the value, then the separator. Okay, I will make it look slightly better by creating a variable called old value, which is text, and set it to this little function call to get the old value and then I will assign the old value to the current token. Old value. Yes, don't need that. Okay, so new array, old value separator. Okay. Else I will add to the array. Alright, put that here at the moment. I will add empty to the array. Alright, put that back here. Okay, and then I will set our array variable to the new array. So here we still have that. Okay. What if I will add some other values? I will do the random thing I did. Get. We can keep that. System repeat with time and set at x loop index random 10 to 20. The thing I did some minutes ago on the array to check how it worked, I will do the same here and then print the array to see okay, it's a big mess. It's a big mess. Oh yeah, I print in the loop. Shouldn't. Okay. Okay, so we have probably 10 random numbers. I will floor them so it's easier to read. Okay, we probably have 10 random number from 10 to 19 because it's it will never reach 20. Okay. Now we want to set the size to something smaller. No, first bigger than smaller. It should add zeros and then overwrite. No, discard the values rather. Okay, so set size, call function, set size to, it was 10, we'll make 20, 1. This value won't be used, but for now I will set them because we will use them soon. Print array, and then I will squash the values and reprint the array. Oh, we can put everything in the same event. Alright, check. Alright, working super well. Okay, we made a one-dimensional array super easily. So now, how do we transform this one-dimensional array to a two-dimensional and a three-dimensional array? Well, as a matter of fact, they're almost the same. I took almost 1 hour to get to the point. A two-dimensional array is just that. You have a bunch of data. Let's say you have an array of 5 elements. Actually, we'll make that even more readable. You have an array of 5 elements. In our string, it's, let's say, 0, 0, 0, 0, 0, 1, 2, 3, 4, 5. It's like that. You have a one-dimensional array. Now, you want a two-dimensional array. A two-dimensional array, which look like, for the size 5, 1, 1 is this one. Two-dimensional will be 5, 2, 1. A 5, 2, 1 array is just that plus that. This is a two-dimensional array. And basically, in our array, it will look like that. So now, what is the difference between this and this? Because here, it could be this or this, it's the same thing. What is the difference? The only difference between this and this is this and this. It's the metadata. It's not how the data is in the array itself, it's how the data is read. How will you read something like, for this array, get at 5. Get at 5. 1, 2, 3, 4, 5. No. Get at 4. Get at 4. We'll go to the 4th index. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But what if you want to get 4, 0 here? If you want to get at 4, 1, 4, 1 is 0, 1, 1, 0, 1, 2, 3, 4. It's this one. It's 0, 1, 2, 3. Yes, it's here. How do you find the proper value, since you just have a stream of data? How can you find the your 2D array. In your 2D array there are 4 one index. Well, it's just 4 plus anything you put this, we'll call that y, multiplied by width. It's x plus y multiplied by width. It's 4 plus, oh, I will write it here. It's x plus y multiplied by width. It's 4 plus 1 times width 5. It's 9. You see, two-dimensional arrays are just one-dimensional arrays, but with a little arithmetic tricks in it. And I let you guess what the depth will add to the mix. We'll see that in a moment. So what will be a set at xy in the end? A set at xy will be a set at x by converting these values with the formula we just seen. So it's a call function set at x with f dot param 0 x plus f dot param 1 times width no more, no less. We'll do a get at xy now. Get at xy get, what is a get at xy? It's just a get at x with that. Simply. But don't be fooled by my simply answer. I can be wrong. I can totally be wrong, and because I didn't prepare this video, so I will check if I'm wrong, right or wrong. I will first set values. Oh, there's something I have to do first, is the set size. I won't be able to use that properly if I don't have a proper size for my array. Okay, so because I will be out of bound, and I didn't handle out of bound, I will do that right now. What happens in the proper array, in the C2 array, when you ask for an index that is out of bound? Let's see. We'll continue our mess. I will set size is 10. I will fill the array with data. So for each x values, arrays set at x, self.cur x, random floor random 10 to 20. Okay, and then I will want to print the value at let's say -1, and the value at 11. So array at -1 and array at 11. Okay. 0 and 0. Basically, if the value doesn't exist, it returns empty. So, if the value is out of bounds, if the index is out of bound, it returns the 0. Let's see what returns our functions first. Maybe it will return 0, I don't know. Get rid of that. And here, get, I will add call function, print. I will just add a new line just to separate what we are doing, and print array, get f.call get at x. Our array now is size 5, but I will get at 50. Let's get crazy. Okay, it returns nothing. It returns empty string. Here, you have an empty string here. So, if we want to mimic, it's not a bad thing actually. What does -1 return? Empty string as well. That's not a bad thing, but if we want to stay close to the original array, we should return empty, and we should you should control. It should be something that you control. It shouldn't be oh, let's see what C2 will return. You should expect values. So if index is greater or equal to width, or index less than 0, I will do a or block. Array, no. Oh, so it's not a set at x. It's but it will be a good idea to check for out of bound. It's a get at x. Index. Oh, yeah. Okay. Okay, here okay, and here index right here. So copy this one, else we return the proper values, we return empty. Okay, now what happens here? Okay, it returns 0 now. What happens in a proper array if you want to set a value out of bound? Let's see. We will display the array, okay, and print array dot at something crazy for each element. That's not what I want to do. Here I want to print all the elements. I lost myself slightly, and here I want to set an out of bound value. Here I set in the array something that is out of bound, and here I print everything in the array. So I print array at array.cur. Oh, I could simply just do that. Okay, 0, 0. So the value is simply not set. If I do -1, the other the other behavior I would have expected is if you set a value larger or lower than 0 or larger than the width, larger or equal than the width, it would clamp the value to the width -1 or 0 and set the value. That's not the case, and that's I think that's better like that. I wouldn't want something to get added in my values. Set at x. This loop will run with time, so loop index will never be equal to something out of bound, so it's okay. Nothing will be never added. Set at x. So now there's something with that that won't work, but we'll continue with the set size. The set size should, let's see, now with the height you should do a loop on all your string, your array string, like that. If your array is 5, 2, 1, the length of the string will be 10. 0, 0, 0, etc. 0. So it will be that times that. So here we will run the loop as much as we will have tokens. But we will need to copy, we will need another arithmetic formula to copy from, you will have the loop index. Oh, do we? I can run nested for loops from 0 to width 0. Yes, it will be. Else you will have to handle a mathematical formula slightly more involved with modulo and stuff like that. So I will use for loops now. So here for the x from 0 to width, then underneath from y from 0 to, oh, I made a mistake, height -1. You have width elements, but they span from 0 to width -1, height -1. I will probably hide the depth soon, but first thing first. Old value will get copied here. We will copy this thing here and get at xy loop index, nope, loop index x, loop index y. And you will notice that it will work with one-dimensional array, since y will go from 0 to 1 minus 1, from 0 to 0, so it will go just once here and it will be equal to 0. So you will have loop index plus loop index x plus okay. Here with if you have a one-dimensional array with this loop, you will have from 0 to 0, so it will go here only once per x loop, and this will be equal to 0. So in the formula we've seen some minutes ago, it would be x plus 0 times width, so it will be x, it will be get at x, and it will be okay. It will automatically work. So x old value, and what we can expect is that with depth it will work as well. Made a mistake here, no? Yeah, I made a mistake. New width and new height. Alright, you get the proper values, and you add it to new array. Okay. For each x, for xy, for x. Oh, there will be a problem. It should be inverted. Let's see why. Here I'm adding a token each time, and what we've seen so far is that I want to add first the first height, and then the second height. Let's use the index. And here 1, 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. So you have to have the parent loop to be the height loop first, and then the width, the x loop, if you prefer. So I have to invert the two, else you will have, what will you have? You will have that one, then that one, and that one, and then that one, and that one. The array will be all messed up. So you need to do that, and the depth will probably be one step higher, but we didn't yet we created no, we didn't created the XYZ get XYZ. So working if alright, loop index. Alright, there's still something. What if width is reduced? Okay. If width, and get rid of that. Yes. If we are out of bound, we don't get the values. If we are inbound, we get the values. So if loop index x is less than width, and loop index y is less than height, you insert the old values, else you insert an empty value. Alright, that should work. Let's see. Okay, seems to be working great. Now let's see with a two-dimensional array. Did I? Yeah, I think I will set 2D here, and set size, get values, and set values. Set size. Set size 5 on 5. I will set at XY I will print the array after this step. I will print the array after this step. I will set at xy 8. I will set xy no, oh, I'm out of bound. 5 5, it's 4 2 new plop. Let's see, 4 0 some stuff. Okay. What do we expect is a long stream of 25 tokenized 25 token. We expect that the fourth 0 1 2 the fifth one yes, we expect that the fifth one will be some stuff, and the 2 4 10 the 15th one to be new plop, etc. Alright, let's see how it doesn't work. It doesn't work at all. Why? Let's see. Okay, I didn't put the value at all. f.parent 3 2. Starting to mix up everything. Okay, some stuff. Alright. What did I... so this one didn't work. How many... oh, the set size didn't work as well. 5 5 0 1 2 3 4 5 6 7 8 9. We have 10 elements. What did I do wrong? Set size, new array, old array, new height, 0 1. Why add? Oh, haha! It's working so well that it's keeping the old value works. It seems. Height. Oh, that's not good. New width is minus. Unexpected. Set size. What did I put in set size? 5 and 5. Let's go down to here. Here it's 5, here it's 5. It will go from 0 to 4. It will go from 0 to 4 here as well. 0 0 less than new width, less than new height. Old value get at xy, new array add token. What's going wrong? Alright, array to new array. Everything seems okay, but it's not working. Alright. For debug, I will check how much time the loop is running. Call function print loop index x, loop index y. Kiat joined us on the chat. Alright, 1, 2, 3, 4, 5, 6. It goes to, alright, set size, and there, that's what we want to the array. That's exactly what we want as far as value goes. But here, get at xy, it doesn't work, or is it? It's working, but the array, oh, I found set. It's only setting things. No, that's not it. It's not a problem of setting or adding. Why doesn't it work? Set new, oh no, odd value is okay here. Can even put it here. New array is set here in the loop. I will look at the result new array. Yeah, Cat is not following my stream. He's just here to laugh at me. Array. Okay. So it seems 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. In French. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It looks like it works. Maybe I misread something. Oh yeah, it's here that it gets shrinked. No, that doesn't make any sense. Why does it shrink suddenly? Oh, I know why. I forgot something. When you set size, you have to update your metadata. You have to set value width to new width, height and depth. New height and depth. New depth. Set size. And this one was right. I want to know if there are former values before. Here it means former values exists. No former values. Empty. Alright, should work now. What the... yeah, okay. Depth, alright. I will toggle off, since we are not using depth for now. Alright. It's weird. It's working here, but here when I say set at xy, oh, okay, the set at x doesn't use the height and the height and the depth, and it should resemble something like that. So here in my mind I'm thinking I will do the same thing here. Is it something I should make a function for? I don't know. For now, I don't think it's exactly the same thing, since here in set I don't have access to something out of bound. Here I am creating something that is out of the bound of the previous array, because I'm creating a new array. Here I'm creating a new array, but it's just to insert something, so I shouldn't be able to loop outside of the array. So okay, it will be a for loop for x from 0 to width -1, and on top of that for y, and loop index. I have to check if here I will have an x index and a y index. Y will be param 1, this one will be param 2. Okay, and I have to check if both loop index are equal, but I will do this the other way. X equal loop index, it's the same, just an old habits, just to have maybe something in bold, I don't know. Y, okay, as I will mirror attacking. Okay, call. What do I do here? Here I set the value. Oh, I'm setting. Yeah, okay. I'm adding the token corresponding to what we have here. So I will have to use the. No, I'm okay with that. Yeah, I'm okay with that, actually. Token at loop index, that's where here I want the old value. It's the same as here. I will explain shortly. Oh, yeah. Copy. Okay. At token new array, it's almost the same, but not quite. Okay. Token new array, all value get. Okay, it should be working. Here I want the old value. The easiest way to get the old value is to use the function I already created to get the old value. I was doing twice the same thing here. In the set at x, when I was using the same expression I use here, but here I will Control Z. Here the token at array loop index separator is the same, except loop index here is the param of the get. Loop index here, the param, well, at the get at xy, because we created it. Okay, so it's the same. It should work now. almost. At least we have the proper ones. What's not working? This never happens. It looks like this never happens. 0 width. Okay. Height, but that's not the only issue. New. I will check though. That's not the only issue. And I broke everything actually. Value 0. Oh. Set at X. Alright. That's a problem. Or is it? Yeah, that's a problem. I think we should implement that the other way around. Let me explain. Here I'm checking for boundaries, because when I set at X I expect, oh okay, no, that's alright. What I can do is a set X at, I will do a kind of hidden function. I will do a set at real index. Because here there's something going on that that is not right. Here I want to be able to set at the, I want in this function to be able to treat my string as a one-dimensional array. So using the real index, the real token, when I use set at x, set at xy, and set at xyz, I'm kind of faking something. I'm kind of faking 3 dimension by some arithmetic voodoo. Because set at xy is the same as set at x plus y time width, and set at xyz, we will see that shortly, is the same as a bigger expression. We'll see. So I want to have a function that shouldn't be used, which is set at real index. The conversion will be done by the set at x, the set at y, and the set at z, but then the actual setting should be done here. So for now I will set at x, y, z. No, I will just hide the real index here. So I will repeat width time. No. Okay. I will put that over there. Repeat. It will look like, it will be exactly like the set at x we had before, but we will reserve the set at x to check for proper width, height, and proper value entered. You will see. Repeat at width, time, height, time, depth. Yeah, I'm starting to add the z because we are starting to run out of too much time. So I will speed up slightly and integrate the z part as well. So yeah, here we'll loop through all the possible dimension of our array. This one doesn't, and it will look at our entire string as a one dimension. It's kind of a flat flatten the array, add value in it, kinda. Alright, so here we won't be able to use that because we are kind of going behind the system, and it will be array loop index and value separator. This will be the old values and we add to the new array. Alright, new array, and here we add the value to the new array. Okay, so I have to rewrite my set at x. Set at x will do something like plus width plus, no, it will just do, if you have an array of 5, 5, 1, will stay, for the example will stay in 2D, and I want to do a set at x 4. It will go to 4 times 0 plus width, etc. So it will go to 4. But if I say a set at x 10 or 9, or rather 9, set at x 9, what should it do? It should do nothing, because this value is not a proper value. If you want to go to the real index 9, you have to say set at x y 4 1, because it's 4 plus 1 times width, which is 5. If you do that, you are saying I want to go to something that doesn't exist, something that is out of bound. So you have to check. You have to check the boundaries here. Escape. Okay. Set at x. So you compare the function parameter. 0 should be less. Oh, I prefer using a variable. It's clearer. Okay, x, big X. Okay, big X. Set value x to f dot param 0, and you check that this value is less than width. If it's less than width and over 0, so you can use this one, value x between 0 and width. Alright, equal, and here it shouldn't be equal. Alright, if it's that, you can do a set at real index. Simply the index will be x, because when you do a set at x, it's the same thing as if you were doing a set at x 1 and 1. Am I right? No, 0 0. It's the same thing as if you were doing a set at x 0 0. That's where you can see that 3D, 2D, or 1D array, they are the exact same thing. There's nothing, it's just a stream of data, and the index are just some kind of offset. But here we'll go the simple way, and the real index expects one value, so it was more like plus 0 time width plus we'll see the expression for y for z shortly. I prefer not typing because I didn't really think about it, so I have to write it down first. So set OK. Set at xy is the same as set real index, this formula. Alright. Set at xy, do I have that? Don't know. X times y plus y time width. Something is wrong. Move. Good. It's better looking. Do that and that. Y. Alright. Get should work. Should I check for boundary here? I should. Should here exactly. Should check that y is well within here. Else I do nothing. And if I get something that is out of bound, it was 0 if I recall. Get, where are you? Else empty. Alright, get at x index. I will change that for x. Makes more sense. And here I will put x. Get at x. That's where. Oh, I should use the. Is between. It's made for that. Oh. Make or. Alright. Get at xy should have its own. I think I should do the exact same thing I did here. Get at real index. Which will do index. I don't do the check here. I throw the index here. Alright. And here I do f dot call get at real index x. Alright. For xy I should have. Alright. First copy that part. Then copy the y part. Y and check if it's within boundaries. Y, no, x and y. Alright, cat is hungry. Bon appétit. X, okay. Else you return empty. Oh, x, it's the opposite. You return empty. Alright, let's see if I messed up. Still not working. Alright, I'll go through everything. So first, our first test don't work. The set size is working, but the get and set are broken. Alright, set at x 5 doesn't work. Let's see. Set at x, I set 5. Here I should get 5. Oh, yes, no, what? Oh, okay. X 0. I didn't choose this condition properly. Yeah, I think I don't know, lower bound here and value here might make slightly more sense, but let's continue with that. I don't think Ash would be able to change that easily without breaking some user's capex, so we won't complain. The functionality is here. Yeah, messed up the order. Be careful if that happens to you. Alright, still broken. We'll succeed. We will succeed. Alright, set at x here, set at x here, 5. Here equal 5. 5 is within 0, x and width -1. Is it? Yes, it is. I set size at 10 first. Okay. Set xy, set at x, set at real index. I mean, yeah, there's something you can check when you are doing that, is the F12, and indeed I'm using a function parameter out of bound. It means that I try to access the index 2 when I have only one parameter available, which is right. No, which is wrong. Alright. Set at real index should have that. Set at x. I forgot to set the values. Set at x, where is my alright. Set at x should have 2 arguments, value parent 1, set at index value. Let's check set at xy. Alright, so I was missing something. Values parent 2, and here set at not x but real index here, and the value. Alright, let's check. Almost there. Not number. I know why. It's the same exact issue we had. And okay. Alright, working. In French. 0, 1, 2, 3, 4. Alright, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14. I was expecting 15, but I probably messed up my calculation. Alright. Still nothing important in the chat. Okay. Oh, I just realized I did extend the construct underneath the chat, but fortunately I don't think I go too far with my expressions. That's not always the case. Well, there's the set and get at xy. Let's see. I will tidy up everything. Get at x with set at x. Set size. hidden a group, yeah. Hidden functions. Functions the one who is using the array shouldn't use. Up. So we have our function get set. Alright. I will implement the depth is implemented here. Alright, but not here. What? What did I do? What did I do? Oh, alright. Okay. It's implemented. Everything is implemented in these functions. What I have to do is the remaining calculation between 3 dimension and 1 dimension. Okay, that's nice. That's nice and simple. That's with the calculation on top. Well, the set at xy calculation, yes. The set at xyz will be one step further from these functions. So I will copy them, rename them, and get rid of this one. Alright. Okay, so we'll have a last dimension z here as well. Z from 2 3, and here z from 2. Alright, now we will have to check the depth. Alright, here as well. And the only remaining thing we have to worry about, it's not get at x. Why did I do that? It shouldn't even work. Get at x, get at xy. No, it gets real index. I think I didn't even check the get at xy. Surprise. And now we have to find out the calculation. Let's see, I forgot something here. It's x and y. Alright, check. Alright, so the calculation. Alright, what is, so I will control. Alright, what we have done until now is 1D array, which are just a stream, a simple list of value. A tree array is a simple list of value as well, but we just have one main different thing is width and height on the same. The metadata, the thing that describes the data, are different. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here we have a width of 10, height of 1, and depth of 1. Here we have a width of 5, height of 2, and depth of 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's our second dimension. Alright, here we have whole list. So now we want a third dimension. Let's say we have the problem with adding a dimension is unless I lower these values, I will have something very big. So I will try, let's see, 2 times 2 times 2, 3 times 3, 9 times 2. Let's say, okay, 3, 2, and depth equal 2. A width of 3 is something like that. 3, 1, 1. If you want another height, you will repeat that as much as you want height. So là, here we have a 3, 2, 1. Now if you want a 3, 2, 2, we have to repeat that part 2 times as well. Oh, alright, I'm still within the boundaries of the window. Okay, so here we will have depth the index equal 0, z equal 1. Here we'll have y equal 0, y equal 1, y equal 0, y equal 1. And here you have x equal 0, 1, 2, 0, 1, 2, 0, 1, 2, and 0, 1, 2. So, how do you access the cell at 1, 1, 1, 0, 1? Let's start simple. How do you access to the cell 1? You said this one is 1, x equal 1, y 0, z 0. Okay, so you want the real index. I will change my color to blue. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here you want the real index to be 1. Here, if you want to access the 1, 1, 0, you want the real index in our real index functions to be 4. Here it's still a 1, it's y equal 0, and it's z equal 1, and you want 7. And let's say you want this one as well. 1, 1, 1. It will be 10. So now we have to find the relationship. When we were only 2 dimension, to go from here to here, we'll just have to add as much width as we need. To go from here to here, you have you have 6 elements per Z group. So each time you add 1 to Z, you add 6. What is 6? 6 is the amount of width you have on an axis multiplied by the amount the number of Y element. It's width multiplied by height. It's 3 times 2. So to have the starting index of a new Z, it's width times height times Z. So the offset given by the third dimension is this formula. For the second dimension, the one we've seen before, it's, I can't erase, so I have to be ugly. It's width times Y. And the offset of x is just x. Let's see if it works. Here we have, first, it's the solution to the equation is ça. Ça in French means this, so I'm mixing French now. It's x plus width times y plus width times height times z. Let's see if this formula works. Here we have 1, 0, 0, so it's 1 plus 0 time plus 0 time, so it's 1. Okay, now it's 1, 1, 0, it's 1 plus 1 times 3, 1 plus 3 equals 4. Alright, now it's 1, 0, 1, it's 1 plus this part is 0 plus width times height is 6 times 1, 6, so it's 1 plus 6, it's 7. And here 1, 1, 1, it's x equal 1 plus width equal 3 times 1, so it's 4 here, and here it's 6 times 1, so it's 6 plus 4, 10. Okay, so this is the big formula we need to convert this into the real index. Alright, so the formula you need here, you just have to copy it back. It's plus z time, you don't need the parenthesis, but it's clearer to me. Height. Alright, and here same. Alright, and we should be done for our fake array. We will do some new tests, run some new tests. First, check the get at xy is working, since we didn't try it. Remove. Right, get at xy for 2 should give us new plop, but I'm not using it correctly. I should, since it will return a value, should use it like that, as I won't catch the value. Alright, I should get at 4, 0 some stuff, and I should get at anything else, like 2, 0, I should get 0, and here should get some out of bound values, since it should be 5 here, and here I should get as well some out of bound values. -1. Alright. I think we can agree that it's not working. Why it is not working? Get that xy. Alright. Looks good. X at 4 and 1 is within the boundaries. If we are within the boundaries, get at real index. X plus 2 times width. 4 plus 2 times 5, 44. What did I say? 14. Get at real index. Index equals 14. Array 14 separator. Alright. It's not working. So now I have to check. First, I'm calling the right functions. Yes, no error here. Get at xy. Get at xy. It returns empty. Let's see. Call function return and out of bound. No, that's the name of the function. Print out of bound. Alright. It's expected here. It's expected here as well. And it's not working. It's expected as the last one. Oh no, it's okay. It returned first empty and then out of bound. So these ones are working great. These ones aren't working at all. The first ones here, I can try to print the value I'm passing as a argument. Let's see something. Yes, should work. Print. I need to add a bit of string to be sure. Real index. Real index 14, 4 and 2 should work. Should work. Why is it not working? Return value. Oh, I know why it's not working. I didn't get the return value from that. Alright. I'm still not using that properly, it seems. So, set return value to get at real index. It's a f.call with the expression here. Alright. Get at xy. Get at x is probably the oh no, it's not the same. I did the things right here. Okay, but here it's probably wrong. Alright. Okay, let's see. Okay, working. I left something. Wait, some stuff. Why is it working like? Oh, okay. All right. It's okay. It's the old values I'm getting. Okay. Just need to test the third dimension. And I think it will be all for today. It was quite a big walkthrough. Now you probably understand why I say it's not a tutorial, since I doesn't know really what I'm doing. Alright, set at, we'll use the values we know, and set at XYZ, Z. Alright, 2, 1, 1 at parameter. 3D is awesome. Okay, set at 0 and 1 here as well, and I will save. And let's see, but not here. I'm trying to make it fail by putting not here. Probably won't work. Alright, so here we should have an array with 3, 2, 2, and it should squash the values 3. So I should have this one remaining. Oh, we'll see. Alright, let's see. Alright, it's not working. 1, 2, 3, 4, 5, 6. I should have a dimension of 12. Right, set size, because I never wrote anything about depth in the set size function. It should look like that. Z. New depth toggle, and here set at XYZ. Get from XYZ rather. Okay, I think should work now. Alright, I set something in the last one. Let's see. 3, 2, 2, the last one is 2, 1, 1. Okay, so that's normal. Here as well, 1, 1, 0, 1, 1. So first X, last Z, and second Y. So I have 2-dimension X, so that's my last 2-dimension X. Alright, my before last at Y, no, Y is okay. That's when debug is slightly harder. Here is my Y, my last Y. Alright, let's see. I have 3 dimensions per Y. So it's my first X, my second X, my third X for the first Y. The first Y is here. The second Y is here. No. Bullshit. 3. Okay, 1, 2, 3 is a Y. 1, 2, 3 is the second Y, and then I have 2Y per Z, so I have 6 values per Z, so 6 here and 6 here. Alright, seems good. Here it's X equals 0, Y equals 0, X equals 1, Y equals 0, Y equals 1, X equals 0. Yeah, 0, Y. Okay, working. Slightly hard to read, I have to admit, but I think it's working. Y1. I think it's working great. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Alright, we can say that we have. Let's test first the get functions, but I think that we succeed at mimicking the array with just a string, which should show you that an array is nothing more than a list of data, and that any dimension is just something arithmetically faked. I will get all the values I set. So by showing you another way to see array, I hope you will understand them a bit more. It will be less daunting, and that you will be able to answer the question, and what if I want a fourth dimension? Alright, working. Out of bound returns 0, and well, I could check this one, which would be 2 at x, 0 and 0 at y and z. Should return 14. Okay. Ah, yes, it's random. So it returns 18. That's alright. So I think I will save. I will stop here. And Kiat left the chat room. Alright. And yeah, I hope you liked this one. It's I must admit it was a bit hard, probably a bit hard to follow. I'm waiting for your feedback, and I hope you at least learn some stuff. If you have any question, feel free to post them on the forum or underneath the video or anywhere you can reach me. I think I will at some point try to answer the question about the RPG problem that was asked. This one I answered Toby maybe for slightly more precision, but I think now that I covered a bit on arrays, you'll see that data can be represented as dimensional stuff or just as a list of stuff. It can be represented as a string, can use that in an array, and we will probably find some solution to answer this interesting problem for RPG. To buy, if you hear me now, if you were able to keep up to 2 hours and 30 minutes, don't hesitate to give more precision to maybe your own project, how you did it, and because it can direct me to one specific thing. Here with the array, you can see that I took. I thought I would be able to make it in 1 or 30 hours. It's almost double my prevision, and maybe by narrowing down your question, I'll be able to make a video slightly smaller, easier to watch, etc. And anyway, I think that's enough. I have to go to the bathroom.